Hi. Today I'm going to go through a brief tutorial on the Magrittr package in R, and in particular how to use the pipe operator from Magrittr. So let's get started. Magrittr is a part of the tidyverse ecosystem of R packages, which is quite extensively used in the community at this point. So other important packages in that ecosystem are dplyr, tidyr, broom. These are things that you'll see people talking about online if you start looking for sort of modern R code. And Magrittr is a fundamental building block that sort of makes those packages as useful as they are. They wouldn't be anywhere close to as useful as they are if it weren't for Magrittr. So Magrittr's fundamental contribution, and this is, again, I can't stress that this is an important contribution to the R ecosystem, is the introduction of a pipe operator, which is denoted thusly. I can write the pipe here. So it's a %, greater than, and a %. And so this operator is a workhorse. I make use of it extensively. Maybe I make use of it too much. But once you start using it, it becomes extremely natural to just use it for everything. So what does a pipe do? Well, let's run this so that we have access to the pipe. What the pipe operator does in a nutshell is it'll take whatever's on its left-hand side and pipe it into the first argument of the right-hand side. So as an example here, suppose we just want to write some R code that will compute the square root of 2. So typically we would just go square root and then bracket and then 2 and then close bracket, and you run this, and RStudio Control Enter runs it in the console, and so we see that the square root of 2 is in fact 1.414214. And this is still, how I would do it. I wouldn't use the pipe for this, but you could use the pipe for this by going to pipe square root. And running this is going to give us exactly the same result as running the square root 2. So what the pipe has done is it takes the 2 and it pipes it into the first argument of the square root function on the right-hand side here. So what's useful about this? Well, to demonstrate what's useful about it, I'm gonna write a little bit of a more complicated function. Actually, I have the code ready to go, so let's paste that into here. And this function is called fibvec. And so fibvec is going to take a vector, and this first line here takes the length of that vector and stores it just temporarily. And then I'm going to return the vector concatenated with the sum of the last element and the second to last element in the vector. So we run this function definition, and then try running fibvec on, say, C0, 1. And that gives us 0, 1, 1. And so if I run fibvec on this again, fibvec can take a vector of any length, right, as long as it's bigger than 2. So I can run this again I can run fibvec on the output of fibvec, and that gives us 0, 1, 1, 2. And I can run fibvec on that, and that gives us, whoops, what have I done wrong? Fibvec on that, and that gives us 0, 1, 1, 2, 3. Fibvec on that is going to give us a 5. Fibvec on that is going to give us an 8. So if you are familiar with these examples in sort of math and computer science, you'll recognize that this is giving us the Fibonacci sequence of numbers. If you are not familiar with that, you should look it up. There's a lot of stuff to learn about the Fibonacci sequence, but we don't need to know everything about it here. All we're focused on here is sort of how this syntax can be simplified using the pipe operator. So what we have here is a function which is able to operate on the thing that it returns. So it takes a vector, it outputs a vector, which you can then pipe it back in to itself. And so this is exactly the type of situation that the pipe operator makes a lot easier. So we can go C0, 1, and then pipe. And this has become such a fundamental part of our programming that there's actually a keyboard shortcut for it. You go Control-Shift-M, which sounds arduous, but you get used to it. So Control-Shift-M to get the pipe, and then R will actually indent these strings of pipes for you. So we hit Enter, and then fibvec, and that gives us the output of running it once. And then we can just pipe again, fibvec, and then pipe again, fibvec, and then pipe again. How many times do we do it? 5, fibvec, fibvec. So again, kind of a silly example, obviously, but you can see the difference here, how much more readable this is than this is, how much easier this is to work with than this. So here we've got this horrible sort of nested concoction of these function calls. You got all these brackets. You got to make sure all the brackets on this side are matched up with the brackets on this side. It's really easy to sort of mess that up. It's in any case, here we know what's going on, but when in less contrived examples, it can be hard to figure out like exactly, okay, so is this one operating on this, or is this operating on like this somehow, or it can be hard to see. This really just opens the whole thing up, and it also you write things down in the order in which they're executed instead of backwards. So here, C01 is the first thing that happens, and then fibvec gets applied to that, and then fibvec gets applied to that, and then fibvec gets applied to that. From right to left, it's backwards. But when we use the pipe, we can express this in a way which is forwards, and that helps with the readability as well. So we're going to take 01, we're going to pipe that into fibvec, we're going to pipe the result into fibvec, pipe the result into fibvec, and this, sure enough, gives us the same answer. And the nice thing also is in RStudio, it recognizes these blocks, so you can just when you're on this block, you can go Control Enter, and it'll run the whole block for you, which is really nice. So where this really starts to come in handy is when we're doing data analysis and we have functions which say take a data frame as their argument and then return another data frame. So an example of that in base R is the subset function. We can have a look at this. So let's use the mtcars data set. This is a data set. It's not a very big data set. It's built into R. You can see it here, and so it's got all of these cars, and it's got some measurements of the cars. So you have a comparison here. And let's suppose that we wanted to do a linear regression. If you don't know really how linear regressions work, I'll do another video on those. But for now, let's just take them for granted. We want to do a linear regression. It's easy in R, where we want to compare the miles per gallon to the weight. So that's WT and MPG. But we only wanted to look at, let's say, 4-cylinder cars. So we can use the subset function for this. A usual way that we might do that would be to make like a temporary data frame. We could go cars temp is going to be empty car subset empty cars, and then we want cylinder equals 4, and this gives us the data frame here. So cars temp. And then we can do our linear regression, LM, and what did we want to do? We wanted to go MPG as a function of weight, and then data equals cars underscore temp. Great. And, whoops, typo. And so that's the model, and maybe we go model equals that. And maybe we want to look at a summary of the model. So this gives us a summary. And maybe we're interested in even extracting this coefficient. So we're going to go coefficient model, and that shows us the coefficients. And we want the second one for the weight. And so that's the coefficient from the model. So, okay, this is one way to go about doing this without using the pipe operator. Now I'm going to show you how we can do this same thing using the pipe operator. And so what I'm going to do is start with mtcars, and we're going to pipe that into the subset function. So the subset function, its first argument is mtcars. So we're going to pipe the mtcars into the subset function. And we haven't seen an example of this, but we're going to see it right now. When the function takes 2 arguments, now it's going to be treated like it has one argument, and that's so in the first argument here, I'm going to put sil equals 4, and this is exactly the same as this. So it takes empty cars, pipes it into the first argument of subset, and then the second argument ends up being that. So we can run this block and see what the output is, and sure enough, it's the same. And so now we're gonna pipe this again, and what we want to do is we want to take this and make a linear model out of it. So we can go lm. Now here we run into what you might think is a little bit of a roadblock, which is that the first argument of lm is actually not this data frame, it's the formula. But thankfully, the authors of Magrittr thought of that. They figured out that we might be in that kind of a situation. And so here's the trick. Here's what you do here. So we're going to put in the formula just as usual, mpg tilde wt, that's the formula. And we want data equals period. So this period here stands for whatever is being piped out of the left-hand side of the previous pipe. So if you don't use this period, then it's just going to pipe whatever's on the left-hand side into the first argument of what's in the right-hand side. But if you want to pipe it into somewhere else, you can do that using this period. So this is taking the result of this and piping it into the data argument here. And then we're going to go, we want to take the summary of that, summary. And we, in fact, wanted to extract the coefficient. So we can pipe that into coefficient. And this is actually going to be a different coefficient function than what we had before, but that's fine. We just want to take the element here with index 2, 1. So this is 2, and this is the row 2, column 1. So we can do that as well using this period, and then index 2, comma 1. And so you can see that this code, when compared to this code, is actually doing the exact same thing. What this code does is a lot more human understandable than what this code does. So this code, you can see we start with empty cars, and then we take the subset, and then we do a linear regression using this as the data, and then we take the summary of that regression, and then we take the coefficients out of that summary, and then we select the 2, comma 1 element of that. Here I only selected 2 because I wasn't, so I could make this exactly the same if I went like this. So it does the exact same thing. You can see that the output is exactly the same, but this is a lot more communicable, especially if you are sharing code with other people or yourself in the future. You could kind of just read along and figure out what's going on here without too much debugging compared to this. Now, when we get started using the tidyverse functions, using dplyr, using tidyr, this becomes just indispensable. There's no other way to do it. You might as well not use dplyr if you're not gonna use this pipe. So join me next time when we go through how to use dplyr and the pipe together. Thanks very much for watching this tutorial. If you have any questions or comments or anything, leave them below. Talk to you later. Bye.